All right. Hi, everyone. Welcome. My name is Mike Hartington. I'm a developer at Ionic. You can find me online everywhere, basically as M. Hartington. And I want to talk about rethinking cross-platform. And let's start off with that idea of cross-platform. Basically, the idea that we have some sort of abstraction around building an app, whether this be for mobile, for desktop, for the mobile web, but we have some sort of abstraction where we can take the code that we write and then be able to port it to these different platforms without having to rewrite it or learn the language of said platform. This isn't a new concept. This is a new technology. In fact, it's used in a lot of places like video game design to make sure that we can get games for Xbox and for PlayStation. Um, it is a well thought out and a well practiced approach to building software. So with regards to how we think about cross-platform and the web, let's kind of set some goals or a baseline of what we hope to achieve with cross-platform. Now, really, we want to achieve three things. We want to reduce the overall amount of knowledge that's needed. Basically, I don't want to go out and learn a whole bunch of native programming. I don't want to have to learn yet another platform. I want to be able to take my code, be able to utilize some tools and some libraries, and basically be able to run it on whatever platform I want to target. In addition to that, it's kind of an added benefit is I want to be able to reduce the amount of code that I need to write. I want to make sure that the code that I'm writing is very lean, very minimal. I'm not having to create code that is going to, or not having to write code that is going to be specific for a platform. My tools in my library should be able to handle that for me, and the code I write is just going to be focused on, the business logic. Everything else should kind of take care of itself. Now, the last and most important part of what cross-platform aims to achieve and what it aims to provide us as developers is to just get to market quicker. It sounds like a real it sounds like a real manager-like kind of goal to have. But if I'm a developer, I want to get something out the door quickly, and I don't want to spend all this time just focusing on unnecessary details. I just want to be able to say, hey, I have an app. An hour later, I have a native app for iOS and Android, and I can be off to the races. Now, with these three goals in mind, we want to, instead of thinking how well do all the cross-platform solutions out there achieve these goals, I want to instead think of their varying degrees of abstractions. Because really, when we start to think about cross-platform and look at all of our different options out there, they're all about abstractions and how we can meet these goals at different levels, right? If we think about the the spectrum of what we have for cross-platform development, we have pure web development, where there is no cross-platform. We're not able to target the web alone with pure web technologies. There's pure native, where yes, we get the platform specific code and we have the platform specific benefits of that, but we're locked into that one platform. Let's take a look at kind of 1 degree away from these extremes and see where we go. And the first one that we have to look at is Cordova, because it's pretty much the first tool that exists to solve this problem for the web. And it's still a very popular option to this day, regardless of what surveys say. So it really pioneered the idea of write once, run anywhere. Basically, the goal was to give web developers sort of runtime or some sort of API that they could call against, and then Cordova would be able to fill in the gaps where those APIs don't exist on the browser. And they really try to push that idea specifically, where APIs don't exist in the browser yet. They really saw themselves as much of a cross-platform solution, but more of a polyfill for the browsers that don't offer the browsers or platforms that don't offer the APIs that we want. Things like at the time, geolocation, Bluetooth connectivity, file system access, things that we're starting to see hit the web now. Cordova was able to provide that to developers 2008, 2009, since its very beginnings. So I think we can owe a lot of success to projects like Google's Fugu for adding more native level features to the groundwork that Cordova set. Now, from an API perspective, it actually wasn't that drastic. We had this thing called Navigator where we could attach all these different APIs on top of it. So, for instance, we have navigator.camera.getPicture. What's this going to do? It's going to pop open the camera activity or the camera view and get us a picture. Let the user take a photo. We have an on success and on fail callback where we will get either a error message or the image data back from our camera. And then we have the quality, the destination, basically how rich of a photo do we want and what kind of data do we want back. File path, blob, what have you. The downside of this, though, is that this navigator.camera API, while it seems pretty intuitive, is only available when we're using Cordova. We couldn't deploy our Cordova app to a typical web hosting provider and expect this to work because we don't have access to Cordova. It doesn't have access to the APIs and, more importantly, the UI to render out what would be a camera selector. So we're kind of stuck here. It's giving us something, but we're also losing out on pure web. Now, that was just the camera, but there are other APIs that were provided for, like I said, things like the file system, for geolocation, for Bluetooth connectivity, all provided by what they called plugins, which were shipped in this highly customized packet format that predates things like NPM. To add these to your projects, they kind of relied on this, I would say, complex build system, but some might say error-prone build system, where the amount of times that we're facing errors installing something or adding a platform, more often than not, those errors popped up pretty frequently. And while that seems like it's a negative, it was just an early day for Cordova. It was just the kind of very beginnings. They're kind of playing and building out all the stuff while none of it existed. Like if we think about what happened before NPM, what was our package management story? We were kind of left to our own devices, and Cordova did the best they can to provide us a solution. And then really keeping the idea of we should try to stay as close as we can to the native web APIs and only polyfill them as they become available. Now, this kind of went to the wayside as time went on, and APIs just were not implemented into the browser following a current spec. And to make sure that they didn't break anything, if an API was submitted under a certain namespace or certain format, they rarely changed them. So the last little bit I will say on this is that when you had a native project or that you had a native app, the only thing that they really wanted you to do with it is to just get that binary out of there and never have to configure that native project. They said the native IDEs were not where web developers should be or deserve to be. So they kind of removed that abstraction away from you and made it a more kind of like a diss target. Like, you are more of a web developer, and this is so many levels of abstractions away from native that you're not even expected to look at this stuff. So This is where Cordova kind of falls in the levels of abstractions. It's very abstract from native development, not too abstract from pure web development. So it falls like in, 1 degree above pure web development. On the other hand of this, we have the 1 degree away from native development, but several degrees away from pure web development. And these are the kind of compiled to native solutions where they give you the idea of having abstractions around the native APIs based on certain languages. And they kind of throw out the idea of having to write once, run anywhere, and learn once, run anywhere. So with this, they kind of promised a truly native app by giving you abstractions around these low-level controls. So you're not going in there creating interfaces with Swift or with Android Studio. You're going in and you have an abstraction around that, sometimes based in JavaScript, sometimes based in languages like Dart. And you're authoring in these syntaxes that are a little bit removed from native, but far removed from the web. Because these APIs and these components don't necessarily exist at the web level in a one-to-one translation. The real nice thing that they do provide is this standard kind of API or the standard library around native access. So nothing is a plugin. You basically have all the stuff provided to you, and then the native toolchain will go through and remove APIs that aren't used inside of the app. Architecturally, all of these compiled to native solutions are pretty simple. You have this this small nugget or the small layer of what is essentially your app compiled. You have this runtime API, whether this is something like V8, JavaScript core, or some highly customized custom runtime and renderer. And then there is this bridge layer that communicates between the runtime and then the native features. So this bridge layer is really what makes all this possible, because you can proxy calls from the runtime out to the OS features. So where this breaks down, though, is having to learn that different syntax and the different languages, and then the different kind of rules for how to build out interfaces. This is something that, if you are doing stuff in Dart, if you're a web developer, Dart is a completely different language with its own set of rules. I now have to learn Dart or learn that tool chain. Same thing for React Native. If I'm a web developer, I am going to have to learn the rules and the kind of limitations of what React Native has that I don't get with the web. And if I wanted to integrate, say, a very popular third-party library, there's going to be chances where I can't do that because it's just targeted for the web. I can't necessarily load up something like Three.js or D3, D3 into my app and expect it to work, because it's just not necessarily built for that platform or that target. So the last little bit, and this might be something that not everyone agrees with, is that the idea of it being quote unquote truly native is a bit misleading. There's still some level of a runtime and a bridge layer, as we saw from the architecture overview, where all these controls are coming from are being rendered at runtime. So your little switch, your scroll items, your list views, all of those are being rendered at runtime by the JavaScript core or the JavaScript engine, or some kind of third-party custom renderer, where they are taking your code, interpreting that, and just basically drawing the equivalent of what those controls would be to that platform. So if that is, 1 degree from native, many degrees from pure web development, where do we fall in the middle, where we are close enough to being pure web development and close enough to being native development that everyone can kind of feel at home. Well, that's what this project that I've been helping out on called Capacitor falls in. Now, Capacitor itself splits up into two different kind of packages or two different tool sets. We have the native runtime and then a JS library where you can start to call out different APIs for the native platforms. And let's focus on the JS library part because this really is the big feature here, is that it can adapt to the different platforms that you're targeting and make sure that you are calling the right things as you're coding against it. So what do I mean by that? Well, if I'm on a web browser, there is a geolocation API provided by the browser. It's very limited though. It doesn't give you all the details that you would want, but it exists. Now on iOS and Android, there is a higher fidelity geolocation API and geolocation service that we can make use of. Capacitor will use that instead of the browser's built-in API. So we're able to just swap out the implementations behind the scenes based on where our app is getting deployed to. But me as the developer, I'm only coding against this one API and it knows how to adapt to that. And probably one of the biggest, coolest features, I think, is the fact that we're just using native tooling. So we're opening things like Xcode, which can seem a little scary. I promise it's not that bad. But we're also making use of things like CocoaPods and Android libraries. So architecturally, this isn't too dissimilar from how these compile to natives, whether it's React Native or Flutter. We have this web app that we are writing, HTML, CSS, and JavaScript, and we're loading it up in this native web view. Now, the web view itself is injecting a lot of the code automatically on creation. So when this loads up, we're able to access those APIs instantly. And if it's done in native, the creation of this web view and injection of APIs is almost instant. The bridge layer just proxies out to these native platforms and gives us the results back and injects those into our JavaScript. So we're able to reuse our existing web skills. We're able to have a runtime that loads near instantly, and we're able to follow the best practices. So this is all just really nice and kind of, me telling you why it's great and what the benefits are. Let's actually see how this works. So I have an app over here on my screen that is using React. It's not specific to React. You could use Capacitor with Angular, Vue, Svelte, no framework at all if that's your thing. But all this app is doing is just loading up my location. Right now I'm hard coding it to say the capital of my state, which is Providence, Rhode Island. But let's go ahead and just open up the dev tools real quick. And I am going to override this to be, I'm in Berlin right now. Okay, let's go and get my geolocation. Well, it's automatically calling the native geolocation API to the browser. It's able to detect where I am and update the map accordingly, which is pretty great. We also have the ability to track the user in their location or just track geolocation altogether. So if I track this and I'm in Berlin now, what if I go to London? Well, now it can automatically update the map for me and just re-render where I am. Now, the code to do this is actually quite straightforward. And we'll bump up the font size real quick and just center this. Basically, we have this function called getLocation. It's async, and we're calling this geolocation API called getCurrentPosition. It returns us the location, and then we set the state for that for our given component. So pretty simple concepts that we're used to working with JavaScript. We're using set state here instead of React, but this could be something like a state management store, NGRX, or something like Vuex for Vue folks. The track location is a little bit different, where we have this location track that we need to keep an eye on. And then we call geolocation.watchPosition. We could pass in some options here. Do we want it to be highly accurate? What's the timeout? How often should we be tracking location? And then we get the location and then an optional error message that's returned back. And then all we do is just say set state on that, passing in some more data. Where this becomes pretty nice is when we track it, we do want to clear it out when our component is destroyed, so that way we're not constantly tracking or requesting this data in the background. Now, all this is doing is just rendering out some UI. It happens to be using Ionic, but you don't need to use Ionic. You could use things like React Material, Chakra, various UI libraries. And all we're doing is loading up a custom map that I wrote using OpenLayers. Now, this is just the browser. It's just doing the location API that you would expect to get from a browser. Let's go ahead and look at the native implementation for this, where we're calling the location API using the native iOS geolocation services. So this is my app. You can see we open it up. We have a full native app setup over here where we have our app delegate. It is loading up the app and the and basically the bridge layer for us. We can configure it if we have notifications. We're basically doing the whole entire thing that we would want to do. So let's go ahead and run this on our simulator. And I don't know if anyone knew this, but the simulator has some pretty neat features. We can customize and override the location to be either a static location. In this case, we're going to say I'm at Apple. Or we could have these custom locations. I could be in London, Paris, wherever, or I could be moving. So we have our app here. It's loading up location again, hard-coded to Providence for now. I set the location to be in Apple. So let's go ahead and get the location. You notice that we are calling the native location service. So we're going to get a little icon up here. We can see that it's printing it out to native, to JS. We're getting the location data printed out. This is great. Let's go ahead and set the location to be a freeway drive. And then let's go ahead and track that. So it looks a little difficult over here, but let's just zoom in and then let the map center itself. And we can see as we are tracking the location, we're getting the coordinates back from native, and we're just updating a little marker on our map. Nothing overly complicated, but we are just making use of the same code automatically, and it adapts to the project or adapts to the runtime that we are targeting. So let's kill this because it's going to run in the background for a little bit, and let's get back to the slides. So this is a pretty nice setup. If you're using Ionic, you automatically are opted into it, but not everyone is using Ionic. Shame on you. But if you want to try this out and play around with it, it's as simple as just saying install Capacitor core, install the CLI, and then run npx cap init, swap out npm with yarn. It'll be the same thing. So we can automatically install this, get a little configuration set up, and then start working and using these APIs automatically. Now, if we wanted to learn more about this, I encourage you check out capacitorjs.com and then the docs section to get an overview of what Capacitor provides, and check out some of the plugins that we have and the APIs that we provide out of the box. If we don't provide something that makes sense for core API, if you wanted something a little bit more ambitious, we have this Capacitor community org on GitHub that we help maintain and organize, where people have been building out awesome plugins based on their own needs for things like Firebase authentication, Firebase analytics, background geolocation services, which would make perfect sense in this use case, where we could track the location in the background, and maintain that service depending on what our needs are. If we're making something like the next Lyft or the post-pandemic travel extravaganza that's probably going to happen, we could build that. Now, this isn't just used by, indie hackers. This is used by a lot of people. Some pretty big names up here that are making use of Capacitor, but also like huge number of community people have been adopting it. It's quickly becoming one of the more popular cross-platform solution projects out there. So something to check out. In addition to that, we also just released our 3.0 beta. So if you want to try that out, we have a blog post on the site, on the Capacitor.js site. Check it out. It's got a lot of awesome new features and a lot of enhancements that people have been looking for. So we're actively developing it. We're actively looking for feedback. Check it out. Now, kind of wrapping up, I want to come back and think about the goals, the ideas, and what we kind of discussed here, right? Cross-platform, it doesn't have to be terrible. We can have nice things like background geolocation, regular geolocation services, without having to sacrifice the amount of code that we write or having to learn new APIs. I should be able to take the JavaScript that I know and love in the UI layer, the front end, the HTML and CSS, and my JavaScript frameworks. I should be able to use that and get a good, compelling native app. And with Capacitor, I think we can do that. So check out capacitorjs.com if you have any questions. Feel free to reach out to me at mhartington everywhere on Twitter. Thank you so much. Take care.